Hello, scientists. Thanks for tuning in. This video is about the International System of Units that is used in scientific measurements. First, let's discuss what a unit is. Let's say I have this pencil and I want to measure it. One thing I could measure about it is its length. I could say to you, the length of this pencil is 10. If that's all the information I give you, does that make any sense? It shouldn't. Hopefully you say back to me, 10 what? 10 miles? 10 fingers? 10 elephants? I didn't give you any context, so the number 10 doesn't mean anything by itself. What we're missing is a unit. The definition of a unit is a quantity or amount used as a standard of measurement. Each unit represents how much makes up one of the measurement. So in other words, there are many different units for different types of measurements. Units are important because it tells us how much of something there is, how big or small. For example, let's look back at our pencil. If I were to describe the length of my pencil from end to end, and I told you it was 10, I have to tell you the unit I used to measure it. This pencil is 10 centimeters long. The unit I used to measure this pencil was centimeters. 1 centimeter is a specific length, and if I add 10 of them together, it would be the length of my pencil. There are different systems of units, meaning that there are different sets of units used by different people when they measure things. For example, in the United States of America, we typically use the US customary system. When we describe the lengths of objects, we use inches, feet, yards, and miles. For temperature, we use Fahrenheit. For weight, we use ounces, pounds, and tons. For liquid volume, we use fluid ounces, cups, pints, quarts, and gallons. You are also probably at least somewhat familiar with the units of the metric system too. For length, the base unit is meters, and it includes all of the other units with meter in it as well, including millimeters, centimeters, and kilometers. For temperature, the units are Celsius and Kelvin. The metric system also uses mass rather than weight, though they are similar. The units are kilograms, including milligrams and grams. For liquid volume, the base unit is the liter, and it includes milliliters. One important thing to note is that scientists do not use the customary system of units. They only use the metric system. The reason why is because the metric system is used most around the world. 192 out of 195 countries have adopted the metric system as their official system of measurement, and only 3 have not. The United States is one of them. So the vast majority of the people all around the world use the metric system, not the US customary system. So scientists have all agreed to use the same units when describing measurements. Because of this, the metric system is also known as the International System of Units, or SI. It has been adopted by most countries and is used between or among nations, meaning it is internationally used. The International System of Units is the system of measurement used by all scientists over the globe. But why is it so important that they all use the same units? Let me give you an example. Let's say I was a scientist from the imaginary country of Flipsburg, and in my country, our unit of length is the flob, our unit of mass is the gizzy, and our unit of volume is the swoop. These units may make perfect sense to me, but if I gave you a measurement using these units, would you have any idea what I was talking about? Absolutely not. You've never measured anything in flobs before, so you can't picture how long that is. You also don't have the tools to measure something in flobs or any of the other units. In order for my experiments and results to make any sense to you, you would need to convert them into units that you were familiar with, either using a calculator or using a conversion program on a computer. This would take time and it would be a pain. Imagine converting every single measurement every single time you were reading about the results of a scientist from another country. That would be so annoying. So, scientists have solved that problem by always using the same system of units. First, doing that reduces confusion because it's like they're speaking the same scientific language. This also allows scientists to compare data with one another without having to convert between units. It also makes it much easier to understand and repeat each other's experiments. In science, scientists often want to be able to do someone else's experiment themselves so they can see if the other person was right or not, or to provide more proof or support for their ideas.